Hello.
Hello.
Good to hear your voice, Amira. How are you?
Yeah, I'm good. How are you?
I'm also good, thank you. Did you start your school?
Yeah.
So how was the first week?
It was all right.
Actually, all your friends are the same from the last year, or usually they just sign
Yeah.
the last ones? Same, right?
Yeah.
Okay, that's good. Now you're going to grade 11.
Mhm.
So you'll graduate this year or next year? It's 12 years, right? Or 11.
It's 11 years, and then after this, I do my A levels for 2 more years, and then university.
Okay, but for A levels, you have to go to school.
Yeah.
So that means
You can
that's.
go and you can go and do your A levels at a college if you want as well.
So it's not this school, right? Anyway, you'll change your school next year, is it?
Probably.
I see. Okay. Okay. I mean, can you see the screen? My screen,
Yes.
actually.
Yes.
Good. No, actually, when did we have our last class? Like 14 days ago.
Yeah.
Good. At least better than none. At least we meet maybe once a week or once in 2 weeks, once a month. Okay, Amir, let me try to remember what we did the last time. Actually, as I remember, we were studying matrices, right?
Yeah. We
And
just started.
okay, and we just studied some operations with matrices, like adding two matrices, subtracting one matrix from another one, and multiplying a matrix by a scalar, a real number. And we did a few examples. And one more thing is left. What is that thing? That one is multiplication of matrices. Actually, basically, we have also for matrices, we have actually six operations. Usually, when we work with matrices, that is addition, subtraction, multiplying a matrix by a scalar, that means by a real number. And after that, multiplication of matrices, that is multiplying a matrix by another matrix. And another one is finding the transpose. We are not going to study here. And after that, inverse, calculating the inverse of a matrix. We will study this maybe today or next week. We will see when we have time. That's all about matrices. And after that, maybe if you just expand this to not 2 by 2, that is 3 by 3 or 4 by 4, and the more general form, it is taught at universities. So at secondary school level, this thing that we have to know one more thing. Actually, I just divided this into another, how to say, chapter, not chapter, that is the second part of this chapter, solving simultaneous linear equations using matrices. Okay, so today we will talk about multiplication of matrices and use of matrices in solving everyday life problems. And from 5.5, maybe I'll show you 2 or 3 examples. And after that, you will solve one example for me here, and we will finish this part of this chapter. So have you ever studied about multiplication of matrices, Amira? Do you have
No.
any idea how we multiply two matrices?
No.
Good. All right. Actually, adding two matrices and oh, let me take my pen. Okay. So adding or subtracting two matrices, as you know, it's exactly the same like real numbers. But at the same time, we're just adding a bunch of numbers or subtracting a bunch of numbers from a bunch of numbers. And also multiplying a matrix by a scalar, that's also actually exactly the same with real numbers. Just multiplying two numbers together. But of course, students also expect that multiplication is something similar to this, but actually it is completely different. It's not difficult, but it's quite different. Number one, first, we should answer the question actually, when we can multiply two matrices. Let's say we are given matrix A, and I want to multiply matrix A by B on the right. And because now soon we will prove that A times B is not equal to B times A in general. That means that we can say that A times B equals B times A. So number one, to be able to multiply two matrices, A by B. Okay. So here, first, let me just write the order of A. Let's say the order of A is M by N. And this one is also, if you want to multiply A by B, then the order of B must be N by P. As you see here, on purpose, I'm just writing N here and here. And the first N actually represents the number of columns of A. And here, this N represents the, what is it? The number of rows of B. If it is so, then multiplication is possible, or we say that it is defined. And now when we multiply matrix A by B, I will have another matrix here. Let's say it is C. Now, what will be the order of this matrix? The order of this matrix will be M by P. That will be M by P. Okay. And maybe it's a bit hard to understand this after practicing a few questions. Actually, you'll see that also is easy, but it is not so, how to say, in a short way, we cannot do this multiplication. It's a bit long, and that's why, but good thing is, we just have to follow a fixed rules. That's why actually most softwares, almost every software, this operation is introduced, or actually it is built in, like in MATLAB, for example, in Excel program, for example. In a lot of softwares, they have matrix multiplication, matrix addition, matrix subtraction. So first, we will start this one. We'll start first multiplying a row matrix by column matrix. Column matrix. Let's say we are given row matrix. Which one is? Let's say 1, 2. Let me just have a very easy one. What is the order of this matrix? That is 1 by 2. If I want to multiply this by B, and this B must have, what is it? 2 rows at least, right? Actually, not at least, exactly 2 rows. And how many columns? It doesn't matter, because we are saying that the number of columns of A must be equal to the number of rows of B. So here, B, let's say there's something like this, 3 and 4. Now, what is the order of this matrix? That is 2 by 1. It has 2 rows and 1 column. The first matrix, 1 row and 2 columns. As you see here, the number of columns of the first one is equal to the number of rows of the second one, right? And if I multiply here A by B, I will have C. How do I know the order of C? So that is 1, right? That's here we have N. This one is P. That is here 1. So that means that this C will be 1 by 1 matrix. That means that if you multiply any row matrix by a column matrix, and if multiplication is defined, and we will have 1 by 1 matrix. Okay. So how do you multiply this now? So A times B. Now I know that this multiplication is defined. We can do that. First, let's just write 1. If we have 2. And matrix B, it is 3, 4. And we are just defining that to multiply a row matrix by column matrix, we should just multiply their corresponding elements or entries and add them up. That means that the first entry and first entry. So here we have 1 times 3 plus second entry and second entry. That is 2 times 4. Let me just write here also brackets, which is equal to 3 plus 8. So the result is 11. That is, let's say, the first example. And how about another example? Let's say A, here we have 1, 2, 3. That is 1 by 3 matrix. And B is, let's say here we have 0, 5, 7. This one is 3 by 1. So these 3, 3, they are equal. So that means the multiplication is defined. And the resulting matrix will be this order, 1 by 1. Again, to multiply this one, A times B, let me just write here 1, 2, 3, and here we have 0, 5, 7. So by the definition, we should just multiply the corresponding entries and add them up. So the 1 times 0, it is 0, plus 2 times 5, that is 10, plus 3 times 7, it is 21. So the resulting matrix will be 0 plus 10 plus 21, that is 31. And why we are defining like this, in a lot of calculations, actually, we actually have to multiply something like this. And that's why actually mathematicians, they introduce multiplication in this way, how we multiply a row matrix by column matrix. Now, in the next example, you will see that, for example, let's say you go to the market and you are going to buy 3 different items. That's the first item. Let's say this is sugar, and this one is some fruit, for example, and this one is, let's say, cheese. And you're going to buy some sugar and the fruit and cheese. And their individual price is, for example, let's say, what's the first one? Sugar. It's not 0. I should put something here. That is the price of the first unit. And this one is the second item, this is the unit price, and this one is the third item, that is the unit price, right? And to find the total cost, we need to multiply, for example, sugar by its unit price, and let's say fruit by its unit price, and here we have, what is it, cheese by its unit price. And if you just multiply this, we will get the total cost. And this is also how it is used in business. In general, if you want to multiply a row matrix by a column matrix, first, actually this nm, the number of columns of the first matrix, is it equal to the number of rows of the second matrix? If it is so, then multiplication is defined. And to multiply this, we should just multiply the corresponding entries and add them up. Another example, let's say here we have C times D. What is C? Let's say here we have 7 to 5. And we have another matrix here. Let's say this 1, 5, 10. So this one is 1 by 3. This one is 3 by 1. So we can do that. And here we have 7 times 1. It is 7. Plus 2 times 5. It is 10. Plus 5 times 10. It is 50. So that's equal to 67. That is 1 by 1 matrix.
Okay.
Oh, it's clear. I think so simple, easy. And after this, actually, you are not going to multiply the big matrices. Let's just do this example, and after that, we will see how to multiply like any matrix by another matrix. Suppose Ellen bought 3 pencils, 2 ballpoint pens, and 4 exercise books. The cost of each item is 15 cents, 25 cents, and 40 cents respectively. Using a matrix multiplication, find the total cost of the purchase. And usually, if you don't have any idea about matrix multiplication, how actually will we find the total cost? We should multiply this 3 by 15 plus 2 times 25 plus 4 times 40. But if you just notice that it's exactly the same with the matrix multiplication. So here, if I just write, what is it? Let's say G, these are goods and their prices. And here we have maybe quantity, actually, right here, maybe quantity. Here we have 3 pencils and the 2 ballpoints, 2 ballpoint pens, and 4 exercise books. Now I need to write here individual prices. Here we have 15 cents. The second item, each one is 25 cents, and this one is 40 cents. And why actually we are writing in this way? Because, okay, here we are talking about 3 different items. How about if we have, let's say, 100 different items, and multiplying each item by the individual price and find the total cost? It's not a practical way. And that's why mathematicians or business people, they thought, how can we do this in a short way? So, or we can write an algorithm for this, so that we can just write one algorithm or program for this, and after that, just press enter. The computer calculates everything and gives us the results. And that's why actually in this way we need to study how actually we can write an algorithm and or how it is working here. Anyway, here we have 3 times 15, that is 45 cents, plus 2 times 25, that is 50 cents, plus 4 times 40, 160 cents, which is equal to, what is it, 205, 255. And find the total cost of the purchase, dot, dot, dot. Total cost is, what is it, $2.55. Okay,
Okay.
good. So find the matrix product of this by this. Okay. In general, let me just write here, if we want to multiply matrix A by B, and we will get one matrix, let's say C. And let's say the order of this matrix is M by N, and this one N by P. Okay, so if we just multiply A by B and C, actually, C means here we have some kind of matrix like this, dot, dot, dots, dot, dot, dots, dot, dot, dots. If I just pick one entry of C, let's say this one, and it is IJ entry. And IJ entry means this C is in I's row and in J's column. This row is I's row, and this one is J's column. Right? This is subscript notation. This is how we show the entries of a matrix. For example, here, the second matrix, how is it written here? Let's say it's B, this 2 is B11, because it's in the first row in the first column. How about 1? It is B12, because it's in the first row in the second column. How about 0, B13? The first subscript notation actually indicates, or is it the row of the matrix? And how about the second one, the column of the matrix? How about this 4? It's in the second row in the first column, so that is B21. The 6 in the second row in the second column, so that is B22. And this 3 is B23. And this, by writing this IJ, I mean IJ entry of C. That means that the entry, it is in the I's row and in the J's column, or at the intersection of I's row and J's column. Anyway, to get this entry, IJ, just we need to multiply row I of A by times and the column of J of B. Maybe if you have never seen this, you may think that, oh, it is very, I don't know, different or complicated. I'm just translating this. Row I of A means, what is it? A matrix I's column, row. For example, if I is 1, I'm talking about the first row here, this one. If I equals 2, for example, if this one is matrix A, we're talking about this row. Or for example, column J of B. That means that if J equals 1, that means that we are talking about the first column of matrix B. If J equals 2, it means we're talking about the second column of B or third column of B. So to get the IJ entry, simply we need to multiply ith row of A by J's column of B. For example, if we need to multiply this, let's say A times B. So here we have 3, 2, 1, 7. And here we have 2, 1, 0, 4, 6, 3. And what is the order of this matrix? First, we have to actually, make sure that this multiplication is possible. So the first matrix is 2 by 2 matrix. The second one is 2 by 3 matrix. So actually these numbers are equal. So that means that multiplication is possible. What will be the order of the resulting matrix? It will be 2 by 3. That means that I will have something like this here. 2 by 3 means it has 2 rows and 3 columns. Here we have 1, 2, 3, 1, 2, 3. So this matrix has 2 rows and 3 columns. So if I just write this, actually using the variable, what we have here, this one will be C11. This one will be C12, C13. And how about the second row? It is C21, second row, first column, C22, second row, second column, C23. Now by the definition, we are saying that, for example, C11, if I want to get the C11, simply I should multiply the first row by the first column of B. This one is A, right? This one is A. This one is matrix B. So to get the C11, I should multiply i's, right? That is first row of A by the first column of B. That means that I should multiply this thing, the first row, by the first column. And to get C12, for example, C12, let's say C12. That means the first row by the second column. How about C13? It means the first row by the third column. It means that to write the entries of the first row, we should multiply the first row by the first column, second column, and third column. Okay, we are done with the first row. And to write the entries of the second row, I should multiply now the second row by the first column, second column, and third column. That's it. For example, C11. What is C11? 3 times 2, it is 6, plus 2 times 4, it is 8. So that is 14. So here we have, the result will be 14. And C12, first row by the second column. So this is the first row, we should multiply by the second column. And we know how to multiply a row matrix by a column matrix. 3 times 1, it is 3, plus 2 times 6, it is 12, which is equal to 15. So this entry will be 15. And here, the third one, let me just write here, C13, that is, we should multiply the first row by the third column. First row by the third column. 3 times 0, it is 0, plus 2 times 3, that is 6. So the result is 6 here. So now we are done with the first row. Now to write the second row entries, here C21, C22, C23, as you see here, this 2, 2, 2 is not changing here. That means that we need to multiply now this second row by each column. So here, let's say C21, second row by the first column, 1 times 2, it is 2, plus 7 times 4, 28, which is equal to 30. And C22, that is first column, I mean the second row by the second column. 1 times 1, 1, plus 7 times 6, that is 42. So that's equal to 43. And C23, that means second row by the third column. Second row 1, 7, third column 0, 7, 3. 1 times 0, it is 0. Plus 7 times 3, that is 21, which is equal to 21. So second row entries will be 30, 43, and 21.
Okay.
Is it clear, or still you're a bit confused?
I'm still a bit like unsure, but I think it'll become clearer.
Yeah, it's okay if you practice maybe 2 or 3 examples after that. Here, what we are doing here is, I'm just trying to explain the theoretical part, but in general, how we are doing this, to write, for example, first, you have to make sure that this multiplication is possible. To do this one, you need to write the order of A and order of B and compare this, and these two numbers, are they equal? If it is equal, actually, if these two numbers are equal, that means that multiplication is defined, if this is possible. Then the resulting matrix will be of this order, M and P, and just write dot, 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 so that you don't get confused. After that, the first row. That first row means you're just writing the first row entries. The first row multiplied by each column and write the results. And after the second row, multiply the second row by each column. If you have more, we just count it in this way. The third row by each column, fourth row by each column, so that we can write all the entries here. Okay. Now we have only 2 examples. After that, I will share with you on file and you'll pack some questions and you'll have break after that. Multiplication of matrices. If A, okay, this, find the products of A, B, B, A, B, C, and C, B where possible. It means that sometimes it may not be possible. Let's start with the first one, AB. A times B, okay. A times B. A is 1, 3, 4, 7 times B is 1, 0, 0, 1. So this one is 2 by 2 matrix. This one is 2 by 2 matrix. We are multiplying 2 by 2 matrix by 2 by 2 matrix. So these numbers are equal, and the resulting matrix will be of order 2 by 2. So that means that here I will have something like this, dot, 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 dot. So to write this entry, that means that I need to multiply the first row by the first column. So 1 times 1, 1, 3 times 0, it is 0. The sum is 1. Okay, now this one is the first row and second column, 1, 2. So we should multiply the first row by the second column. 1 times 0, 0, 3 times 1, it is 3. The sum is 3. Now we are done with the first row. How about second row? To get write the entries of the second row, we should multiply the second row by each column. So the 4 times 1, 1, 7 times 0, it is 0. That's equal to 4. And 4 times 0, 0, 7 times 1, that's equal to 7. Okay, if you notice here, actually that thing is exactly the same as A, right? 1, 3, 4, 7, 1, 3, 4, 7. Why is it so? In math, actually, if you're given a matrix, all the entries in the main diagonal, they are 1, and the rest of the entries are 0. We call this, actually, this matrix is called identity matrix. That is, actually, that serves exactly the same role as 1 in real number algebra. We know that in real number system, if you multiply any number by 1, the result is itself. How about in matrices? If you multiply any matrix by identity matrix, or I times A, the result is A. So what is this I? It's a matrix whose all entries in the main diagonal, they are 1, 1, 1, and all other entries are zeros. Like, for example, it's 1, 2 by 2, this 1, 0, 0, 1. If it is 3 by 3, it is 1, 0, 0, 0, 1, 0, 0, 0, 1, and something like this. All the entries in the main diagonal, they are 1, other entries are 0. And that's why actually is equal to this. Next time, if you see this kind of matrix, even we don't have to calculate this. Immediately, we can just write the matrix itself. Okay, how about B? B times A. This is done, B times A. Now, B times A, B is again 1, 0, 0, 1. And here we have A, 1, 3, 4, 7. And this one is identity matrix. Because of this, the result is just equal to A. So it is 1, 3, 4, 7. And C, how about BC? BC, B is 1, 0, 0, 1. And C is 1, 2, 3, 1, 2, 3, 4, 5, 6. So this one is 2 by 2. This one is 2 by 3. 2 by 2 matrix, 2 by 3. 2, they are same, so this multiplication is possible. The resulting matrix will be 2 by 3. 2 rows and the 3 columns. Okay. So to write the entries of the first row, we should multiply the first row by each column. So 1 times 1, 0 times 4. So that is 1. 1 times 2, 0 times 5. That is 2 and 3. Again, we will get the same answer. Why? Because this one is identity matrix. And BC also the same thing. And because we are just multiplying BC. Oh, did we? Okay, BA. All right. And the BC. Okay, and CB also. How about CB? Let's do the last one. CB. And what is the order of C? That is 2 by 3. And what is the order of B? It is 2 by 2. And see, because of these things, right? 3 is not equal to 2. So that is not possible. Okay, Amira.
Yeah.
So when you're listening to me, you should just, I don't know what you like to drink or eat. You should eat some apples or grapes or drink coffee so they don't get bored. That's the last example, Amira. Let me show this. And after that, you will work. I will watch you, drink my tea, and just listen to you. Okay? Usually also in secondary school, most of the time, you will just see that multiplying 2 by 2 matrix by 2 by 3, or even most of the time, maybe 2 by 2 matrix by 2 by 2 matrix. They don't ask like 3 by 3 or 3 by 4, because also idea is simple, but it requires more time, because multiplying 3 by 4 matrix by, let's say, 4 by 3 matrix, that means that you need to do what is it, 3 by 4, it's like 12 operations. Anyway, another example. Here we are given these matrices. Find the matrix products of the following. Where possible. Okay, actually all are 2 by 2, so all these products are possible. So let's start with A times B. So A is 1, 2, 3, 4, 1, 2, 3, 4, and B is 3, 2, 1, 4, 3, 2, 1, 4. So this one is 2 by 2, 2 by 2. Also the result will be 2 by 2 matrix. Okay, let's just write the entries in the first row. The first one is multiply the first row by the first column. 1 times 3. 3 plus 2 times 1, it is 2. So the sum is 5. And the second one, first row by the second column, that's 1 to entry here. 1 times 2, it is 2. Plus 2 times 4, it is 8. So the sum is 10. Now we are done with the first row. To write the entries of the second row, we need to multiply the second row by each column. So 3 times 3, 9, plus 1 times 4, 4. The sum is 13. And the 3 times 2, 6, plus 4 times 4, it is 16. So 16 plus 6, that is 22. And Amira, can you write on the screen now? Can you do B? You can use annotate, right, using the zooms. We can erase it later, because I talk too much. It's already 30 minutes.
Can you see my writing?
Yeah, I can see. Three, two, 1, 4, 1, 2, 3, 4.
So the first number,
Multiply the first row by the first column, right? That is 3, 2, 1, 3.
okay.
3 times 1, it is 3, plus 2 times 3, 6. There's okay, 9. Okay, the second one in the first row.
Is the second one, is it the first row times by the second column?
Uh-huh.
Okay.
Three times 2, 6. 2 times 4, 8. The sum is 14. Okay, now we are done with the first row. So we need to write the entries of the second row. So we need to multiply the second row of the first matrix by each column of A. Okay, so 1 times 1 plus 4 times 3, 13. Okay, correct. Next. 2, 16. Good. Let's do C, BC. B 3214, C 1023. Three times one, two times two, 7. Okay.
Is that correct?
That's correct. Let's do B. Amir, actually, these questions are put here intentionally to show you something. As you see here in question A, it is A times B. In question B, it is B times A. Right? If you notice here, A and B, are they equal or not? They are not. Right? So this is because it's 5, this is 9, this is 10. Actually, to be equal, actually for two matrices to be equal to each other, they must have the same order and their all corresponding entries must be equal to each other. Since actually even the first 5 and 9, they are not equal, so we can conclude here that we can draw this conclusion that AB is not equal to B times A in general. And what happens if they are equal? Soon we will talk about this. We'll just attach a special name to this. When AB equals B times A, that's equal to, what is it? I. Okay, now just keep in mind that A times B is not equal to B times A in general for matrices. Okay, and also here in D and F, you will see that actually we call this in math associative property, this A, B, and C, and A, B, C. You're just going to show that if you're given three matrices, first if you multiply A by B, and after that multiply the result by C, it is the same as first multiply B by C and multiply by A. Because here order is important. As you know, from here, A times B is not equal to B times A. But if you just do this thing, actually it has this property. If you are given three matrices, first multiply two matrices together and multiply by the third matrix on the right, it's the same as first multiply B and C, and after that multiply by A on the left, it gives us the same result. But we are not going to do here both. We just do one of them. Let's do D. That's enough. Can we do here D?
Okay.
Okay, let's do the last one, and after that we will have break. That's it. How about F?
Which F?
You are right. D, E, F, the last F, A squared. I will correct this. It should be E. A squared in matrices, how do we define square? Very good. That A squared is defined as A times A.
Oh, wait.
Seven. Okay. Good. Finished, right?
Yeah.
All right. Amira, can you read this and let's finish this session with this?
Okay. Yesterday I was clever, so I wanted to change the world. Today I am wise, so I am changing myself.
So what do you understand from this quote?
Instead of trying to change things to make things better, try and adapt to the situation and make yourself better accordingly.
Yesterday I was clever, so I wanted to change the world. Today I'm wise, so I'm changing myself.
Instead of complaining about other things, maybe self-reflect and improve yourself. So instead of changing the world, just improve yourself.
Okay. And sometimes I ask, you just look at the same thing, but everybody thinks differently. That's also interesting. It's like you're just looking at the sky and there's a moon. And if you ask somebody, what does it look like? It says just a circle. Somebody says like spherical. And sometimes or something is shining. It looks like a light. I don't know, different approach. Very good also. Your one is good. But I was thinking that usually people actually, when they complain about different things and they think that actually, you know, there's some types of people, they just criticize everything. And when there's something wrong, they just first blame other people and they think that they are clever. And because of other people's fault, that something negative happened. And after that, by experiencing a lot of things, maybe after a certain age, people start thinking that, okay, first, if you change yourself, it's like you're looking at the world through your window. If your window is clear, you can see everything nice. If your thinking is good, actually just, if, for example, sometimes if you are happy, I don't know, just look, go around and walk around and you see everything differently. The same situation, but if you are not happy, you see things differently. That's why actually, if you want to change the world or your surrounding, or let's say your kids or somebody, first you have to change yourself. You have to change your habits. Then you'll just see that everybody behaves so differently towards you, and you see everything in a, I would say, differently. Anyway, this is how I understand. Actually, of course, I got this from the internet, and I like this quote. And sometimes I like something, I share it with the students and listen to their ideas about this. Anyway, thank you, Amira. Have some rest. We will continue after 12 minutes. Okay?
Okay.
Okay.